This is the semester 1 review. Problem 5a, which is a formula of an arithmetic sequence when the first term is 3 and the 11th term is 23. So what we've got here, when they give us this, it means our first term is 3. That's the same as the 0.13, and our 11th term is 23. That's the same. That's the point is 1123. So when we have something like this, we can always find our slope from those 2 points. So from 3 to go to 23, we're going up 20, and from 1 to go to 11, we're going up 10, so our slope is 2. So that means that our common difference is 2. So what would we need to do? We'd need to set up our equation. So a sub n equals a sub 1 plus the quantity n minus 1 times d. And we'll just substitute in our information. So a sub n equals the first term we said was 3 plus the quantity n minus 1 times 2. And that looks like b to me. Now normally we'd simplify this and we'd say a sub n equals 3 plus 2n minus 2. We'd combine our like terms and we'd get 2n plus 1. But that's the most simplified way to do it. But they didn't do that for the question, so we need to be able to do both ways. To simplify this, 4, 11 halves, 7, 19 halves, let's get them all over 2. So what we're asking is what number divided by 2 would equal 4? And some of us struggle with that. So what number divided by 2 equals 4? And that number is 8. 8 divided by 2 is equal to 4. So we could rewrite this as, instead of writing 4, if we wrote 8 halves, our next number was 11 halves, our next number is 7. So what number divided by 2 equals 7? And that would be 14 halves, right? 14 divided by 2 is 7. Then we'd have 19 halves. And now it's pretty easy to see that from one term to the next, well, we're adding what, 3 to our numerator. So now be careful, because our common difference isn't 3, it's actually 3 halves, because we're actually adding 3 halves because our denominator is 2. 3 to the numerator. So our common difference here is 3 halves. So what do we need to do? Just substitute this in. So we'd say a sub n equals a sub 1 plus the quantity n minus 1 times d. A sub n equals, what's our first term, is 4. We'll write that as 8 halves. So plus the quantity n minus 1 times d, which was 3 halves. So we'd get a sub n equals 8 halves plus 3 halves times n minus 3 halves, because we're distributing that. And now we combine our like terms and we'd get a sub n equals 3 halves times n, and 8 halves minus 3 halves makes 5 halves. So that looks like a to me. Question 6a, which is a recursive rule for the sequence 2, 4, 7, 11, 16. Well, 2 plus 2 makes 4, but plus 2 does not make 7. 2 times 2 is 4, but 4 times 2 does not make 7. So this is neither algebraic or geometric. So let's just see what these say. We'll go through them from there. Remember that t sub n minus 1 means our previous term. So what are we saying? We'll pretend that you're on the second term and you don't know what you don't know that it's 4. We're trying to figure it out, right? So But we do know it's 4, so we'll be able to use the equation. So this is saying take our previous term and multiply it by 2. Well, if we're at this second term, we take our previous term, which is 2, times 2 makes 4. Let's check it with our next one. If we're at 7, does 4, our previous term, times 2 make 7? No. So this one's a no. Can't do that one. Let's look at this one. This is saying we're going to take our previous term and add 2 to it. So if we're at 4, 2 plus 2 makes 4. But if we're at 7, 4 plus 2 does not make 7. So that one doesn't work either. This one's saying we're going to take our previous term and add the term that we're on. That's what n stands for, is the term we're on. So this is our first term, second term, third term, fourth term. So if we take our previous term, right, we're at this term, we're at our second term, and we take our previous term, which was 2, and we add the term we're on, which is 2. 2 plus 2 makes 4. So then if we move to the third term, our previous term from the third term is 4, and if we add the term we're on, which is 3, that makes 7. If we're at the fourth term, we take our previous term, which is 7, and add 4 to it. That makes 11, so it would be C. What are the first 5 terms in the sequence? And this is kind of a tricky one too. This is saying that our next term, a sub n minus 1, that means our next term. And we'd read this not sub, but this is function notation, so it'd be a of n plus 1. It means the same thing. Sub of, just this would be a sub n minus 1. It's the same thing as a of n minus 1. One's subset notation, the other one's function notation. Same thing. So, but what this is saying, instead of our previous term, n minus 1, this is our next term. So the next term equals a of n minus 4. So our next term equals the term we're on minus 4. So if our first term is 3, right? The next term is going to be the term we're on, which is 3 minus 4. So what's 3 minus 4? Negative 1. If we're at 1, the next term, if we're at negative 1, the next term would be the term we're at, negative 1 minus 4. So what's negative 1 minus 4 would be negative 5. If we're at negative 5, the next term would be the term we're on, negative 5 minus 4, which would be negative 9. So that's C here. 7a, a sequence is defined as a of n equals 3n minus 9. Which graph shows the first 6 terms in the sequence? Well, our first term, we'd substitute in a 1. So a of 1 would be 3 times 1 minus 9, so that would be 3 minus 9, which is negative 6. So we should have a point at 1, negative 6. That looks like this one, right? 1, negative 6. Our next one, and we can see this if we look at this, right? This looks really similar to y equals mx plus b, because it's the same thing, really. Alright, function notation and slope-intercept notation. So what's this saying? That our slope then, the term in front, right, is 3. So that means we should be going up 3 over 1. So on our next one, on our second term, right, if we went up, this is the point 1, negative 6. So if we went up 3, that would be negative 3, right? Negative 6 plus 3 would be negative 3. And we're going over 1, that's 2, negative 3. So that looks right to me. Now let's plug in a 2 and make sure. So if we said a of 2 equals 3 times 2 minus 9, well, what's 3 times 2 is 6. 6 minus 9 is negative 3. And so that's that point. The second term is negative 3. So we're just going up 3 each one. It's not a coincidence that there's a 3 right there. graph the first three terms of the sequence. So our first term, t of 1, would be 3 times 1 plus 2. That would be 3 plus 2, which would be 5. So our first term is 5. So 1, 5 right here. And then we can see pretty quickly, right? This looks like slope-intercept form. What's our slope? 3. So we're going to be going up 3 for each one. So our next term should be 2, 8. And let's check it out just to make sure. So t of 2 equals 3 times 2 plus 2. 3 times 2 is 6. 6 plus 2 is 8. So t of 2, our second term, is 8. And so the next term, we'd be going up 3 again, so that would be at 11. Which of the following tables represents a function? Well, remember, for a function, for every input, we can only have one output. So we input a 0, we get out a 0, input a 1, get out a 0. That's okay to have same outputs. It's not okay to have different outputs for the same input. So that's okay, that's okay. That's okay. Now here's our problem. With the same input of 0, sometimes we get out a 1, other times we get out a 2. That's a no. So this one is a no. This is yes. Let's check the third one out. Would be 2 to negative 11, 0 to 8, 2 to 4. So there's our problem. Sometimes when we input a 2, we get out a negative 11. Other times when we input a 2, we get out a 4. So that one's a no. And our next one, negative 3, 2, that's okay. Negative 2, that's fine. 2, negative 3, and 3, 3, 3, those are all fine. So yes, that's a function. We didn't repeat our inputs. That's how you could tell in this, is if it repeats. Not that it repeats, but that you go to different outputs for the same input, like we did on this one. Output of 4, output of negative 11 for the same input. So represents the function would be 1 and 4. Represent the function. 8b, same type of question. 1 to 5, 2 to 5, 3 to 5, 4 to 5. It's okay that they all have the same output. All that does is make a horizontal line, right? Remember when we had our vertical line test? So this would be 1, 5, 2, 5, 3, 5, 4, 5, right? All that makes a horizontal line. That's fine. That is a function. What's not a function is any kind of vertical line. It's not a function. So 2 to 1, that's fine. 4 to 3, that's fine. 6 to 5, 8 to 7, that's fine. This is not good. 5, 1, 5, 2, 5, 3, 5, 4. The graph of that, right, would be out here at 5, 5, 1, 5, 2, 5, 3, 5, 4. That makes a vertical line. That's not a function. No. This one, 9 to 10, that's fine. 6 to 7, that's fine. Not fine because earlier we said 9 to 10. So that would be the different outputs for the same input. So that's no. That's not a function. What did I say no here? This is a function. Yes. This one is a function. Yes. This one, would we say yes? So the only one that's not is 4 here. Okay. Our next problem, 9. Which of the following graphs represents a function? And we're just going to do our vertical line test. So yes, it only crosses at one spot. No, it crosses at multiple spots. No. Yes, we only cross at one spot. And yes, we only cross at one spot. So the only one that's not would be 2. 9b, same thing. No, crosses at 2 spots. Yes, so that's a no. This is a yes. That would be a yes. And this one crosses at 2 spots, so that would be a no. Because why these are no again, look, for the same input, 1, 2, 3, 4. So the input of negative 4, sometimes we get out a, what is this, 1, 2, 3, 4, 5, 6, about 7. So that's 7, and this is about -7. So sometimes we get out a 7, sometimes we get out a -7 for the same input at -4. That's why that's a no. 10a, given the relation, what's the domain? So what is domain, right? Domain is all the input values. So 7, -6, 0, and -1. So that would be the same as -6, -1, 0, and 7. 10b, what is the range of the following relation? Range are all our output values, so that would be 5, 8, 1, and -1. In order, it would be -1, 1, 5, and 8, right? (11a), solve the equation for x. So we need to simplify this first. So distribute. Let's get out of red and go to black. So this would make 5x minus 10. 4 times 3 would make plus 12, and 4 times x would make plus 4x equals 20. We want to combine our like terms. So we'd say 5x and 4x makes 9x, -10 and 12 make 2, and that makes 20. So we'll subtract 2. 20 minus 2 makes 18. 9x equals 18. Divide by 9, and x equals 2. Our next problem, doing the same thing, we'll need to distribute. So we'll get 12x and minus 16 plus 2 equals, and we'll distribute a -2. So -2 and -6x make positive 12x. -2 and 1 make -2. And so what happens here? Let's try and get our x's on the same side. So we say, let's subtract 12x, and now what happens to those x's? They go away on both sides, and -16 plus 2 makes -14, but -14 does not equal -2, which is on the other side, so that's a no. So what happens when we have something like that? That means we have no solutions here. No solutions. Solve for y in the equation. So we're trying to get y by itself, x times y divided by 4. So what's happening? X and y are being divided by 4, so we'll undo that by multiplying by 4. So we get 4w equals, our 4's will cancel, and we'll get x dot y. And now to solve for y, we'll divide by x and divide by x. So y equals 4w divided by x. Our next problem, to find the formula for the trapezoid. So which one of these is equivalent to it? Looks like we need to either solve for h or solve for a. So or solve for b1. So we kind of have a lot of solving to do. So a equals 1/2 h b1 plus b2, and let's solve for h first. So what's happening here? Well, we could divide the whole thing by b1 plus b2 because they're being multiplied by the h, right? So this would be, if we divide it by the quantity b1 plus b2, divide by the quantity b1 plus b2, and we get a divided by b1 plus b2 equals 1/2 times h. So then if we wanted to solve for h, well, what undoes multiplying by 1/2? Multiplying by 2, so that would be 2a, right? Because we multiply by 2, that would cancel, and that would make a 2 on top. I shouldn't have written that 2 in there. Let's make it out here. But then when we distribute it, it would become on top. So 2a over b1 plus b2 equals h. And that looks like B here. 13. Sarah used the equation P equals 8H plus 40 to figure her weekly pay, P in dollars, for H hours. How many hours should Sarah work to earn exactly $320 this week? So we're going to say 320 equals 8H plus 40, subtract 40, subtract 40. This makes 280 equals 8H. And divide by 8, and H equals, well, 280 divided by 8. 8 goes into 28 3 times, that makes 24. 8 goes into 40 5, so H is 35. 13b, same thing. Here's the equation. A car rental company charges a daily rate of $30, daily rate R plus $30 for insurance. The total cost C is calculated using the equation C equals R D plus 30, where D represents the number of days. Jason's total cost was $135 for a 3-day rental. How much was the daily rate? So total cost 135, so that's in for C. 135 equals R is our rate. That's what we want to figure out. R times what? How many days? 3 days. So R times 3 plus 30. We need to subtract 30. Subtract 30. 105 equals, I'm going to change that to 3R instead of R3. And now divide by 3. Divide by 3. And so R equals, how many times is, that's what, 35? Right? 105 divided by 3. We'll do it. 105 divided by 3. 3 goes into 10. Whoops. 3 times, that's a 9. That 1. 3 goes into 15. 5 times. There's your 35. 14a, the length of a rectangular deck is 3 more than 2 times the width. The perimeter of the deck is 48 feet. What is the width of the deck? So draw ourselves a picture. That's not there. Let's see. There we go. So the length of a rectangular deck is 3 more than 2 times the width. So how would I describe 3 more than 2 times the width? L equals 2W plus 3. That's 3 more than 2 times the width. So this is 2W plus 3. That's W for width. And the perimeter, that means all the way around, is 48. So I'm not going to use this L portion of this because we want to just use one variable. And we know that L equals 2W plus 3. So let's add up all of our W's. Our W's would be 2W and 2W and W and W. Well, 2 and 2 make 4, 5, 6. So that's 6W, and 3 makes 6. And that equals 48. And now we'll solve for W. Subtract 6, subtract 6. 6W equals 42. Divide by 6. And W equals, what is that, 7? So our width is 7. 14b, the 189 selling price of a cell phone is $51 more than 3 times the wholesale cost. What is the wholesale cost? So 189 equals, the selling price of a cell phone is 51 more than 3 times. So it would be 3 times the cost plus 51. 3 times wholesale cost, so C plus 51. 51 more than, that means plus 51. 3 times 3C. So subtract 51, subtract 51. We get 8, 338. 3C, divide by 3, divide by 3. So we got a little problem. 3 goes into 138. 3 goes into 13 4 times. That makes 12. That makes 1. 3 goes into 18 6 times. So 46. C equals 46. 15a, graph the solution. So let's simplify this first. So 4x minus 3 greater than or equal to 2 times the quantity x plus 3. Let's distribute. So 4x minus 3 greater than or equal to 2x plus 6. Let's get our x on the left. Subtract 2x, subtract 2x. If I'm getting my x's on the left, right, then I want to get my constants on the right. So we'll add 3 to both sides. And so we'll get 2x greater than or equal to 9, divide by 2, divide by 2, and x is greater than or equal to 9 halves. Well, what's half of 9? 5.5. Sorry, 4.5. So greater than or equal to, closed circle, greater than is going to go to the right, so we're looking for a closed circle that goes to the right at 4.5. That looks like D to me. 15b, solve the inequality for x, so subtract 6, negative 5x greater than or equal to 5, divide by negative 5. Remember, when we divide by a negative, that we need to reverse the inequality symbol. So this is x equal, or x is less than or equal to negative 1.